Okay, so now let us understand what is a 1-1 function. There is another name to this and it is called injective. So you say 1-1 function or injective function, it means the same thing. When do you call a function 1-1 function? For that, let us take some elements in set X and set Y, and we are understanding the mapping under F. Okay, so let us say for a moment, let us consider this to be Y1 and let us say this is Y2. You call a function to be 1-1 function if X1 is mapped to Y1, then no other element should be mapped to Y1. Simple. Got it? So if X1's image is Y1, X2's image can be anything else other than Y1. Okay. So let's say it is like this. So is this function 1-1? Yes. Okay. Let me give you another example. X, Y. Here we have A, B, C, 1 and 2. The mapping is like this under F. Is this function 1-1? No. Why? Because A's image is 1 and B's image should be something else other than 1. Means not only B, anything else other than A cannot take 1. Right? So here B's image is also 1. So therefore, it is not 1-1 function. There is another way of saying the same thing. If you have an element in the second set, which has more than one arrow coming, then that will not be a 1-1 function. There is another way of saying the same thing. If X1 and X2 are different, then their images also should be different. Okay, simple. So let us take the definition. Okay, so now let us take the definition. A function f maps from X to Y is defined to be 1-1 or injective if the images of distinct elements of X under F are distinct. Okay, so if you have a little difficulty in understanding what is this distinct, you can replace it with different. Okay, the meaning remains the same. Okay, so now let us read it again. If the images of different elements of X under F are different. Okay, so that's all. If you have two different elements in X, then their images should be different. If that is happening, then F is called 1-1 function. Simple, right? Mathematically, how do you write the same information? For every X1, X2 belonging to X, for now, let us take it like X1 and X2 are some elements in X. Okay? Consider f of X1 is equal to f of X2. Consider f of X1 is equal to f of X2. Means what are you doing here? You are saying that the images of these two elements are same. No problem. And you go further and ultimately you get X1 is equal to X2. Means this is saying that if the images of two elements are same, there is no other solution other than these two elements being same. That means this is 1-1 function, isn't it? If the images are same, then the elements also should be same. Only then this can happen. Then that means it is a 1-1 function. Let us say you got X1 is equal to X2 or X1 is equal to 2X2 also. Okay, you solved all of the equations and finally you got X1 is equal to X2 or X1 is equal to 2X2. That means, what is it saying? X1 is equal to X2 means the element for this equation, the element should be same, or X1 is equal to 2X2 also gives f of X1 is equal to f of X2. Means there are some solutions where even if the input values are not same, then the output values or the images can be same. Okay, fine. Then that will be many one function. So if you are getting extra solutions, implies many one function. You will understand this very well when we do the problems. Many one function. Okay, very simple. When you solve this, if you get X1 is equal to X2, then it is 1-1 function. But along with this, if you get something else, then it is many one function. Why? Because this is saying that if I take X2 as X1 by 2, if I take X2 as X1 by 2, then f of x1 and f of x1 by 2 have this same image. Means x1 is different from x1 by 2, right? If x1 is 1, let us say, x1 by 2 will be 1 by 2. So f of 1 is f of 1 by 2. So there is a clash here. Means it will not be 1, 1 function. That's all. Okay, fine. If the input values are different, output values should be different. That's all. Okay, so otherwise f is many one function. So opposite of onto was into, opposite of 1, 1 is many one. That's all. So the question will be, means the before the question was decide or check if f is onto or into. Here the question will be check if f is 1, 1 or many one. That's all. Okay. So how do you check it? You start like this. F of x1 is equal to f of x2 and proceed further. If you get x1 is equal to x2, this is the only solution, then f is 1, 1. If you are getting something else other than this, then it will be many one. Okay. So means what I say is, means before I showed you something like this, right? So x1 is equal to 2x2. So you are getting two solutions here. Maybe you don't get this solution at all. You get this solution only, right? x1 is equal to 2x2. That means this is not 1, 1. This is not 1, 1. It's a very simple thing. If you start with f of x1 is equal to f of x2, you should end up in x1 is equal to x2. Only then it is 1, 1. Otherwise, it is many one. Simple, right? Okay, so let us go ahead. Now let us take some sets and let us understand if this function is 1, 1 or many one. So how do we do it? 1 image is 1. 2's image is also 1. Simple. So therefore this is many one. This is many one. Because we have already studied onto function, let us check for that also. There are some elements left over in the codomain. So therefore this will be into function. Okay, very good. Let us go to the next diagram. Under the function f, the mapping is like this. Okay, very good. Okay, so 1's image is 1, 2's image is 2, 3's image is 3. There is no sharing here. So therefore this is 1, 1 function. This is 1, 1 function. Is it onto function? No. Why? Because there are some elements left over in the codomain. They do not have any mapping. So therefore this will be into function. Okay. What is 1, 1 function? If 1 is an image of some element, then it should not be image of any other element. That is 1, 1 function. What is onto function? No element in the codomain should be left over. That's all. Okay. So let us take the next one. Okay. So in all of this, we can check if it is a function or not also. First, is it a function? Okay. So here, for when will it be a function? Every element of domain should have exactly one image, right? That is what is the definition of function. Every element of the domain should have exactly one image. Every element of domain have images. Very good. Every element of domain should have exactly one image. Only one arrow should go out. Yes, that is happening. So therefore it is a function. Every element of domain should have exactly one image. Okay, you can clearly see exactly one arrow is coming out. So therefore it is a function. So is this a function? Let us see the domain. In the domain, all of the elements have exactly one arrow coming out. So therefore this is a function. Is this a 1, 1 function? Let us see. 1's image is 1 and there is no other element which is sharing 1. Okay. So 2's image is 2 and there is no other arrow coming on 2. 3's image is 3 and there is no other arrow coming on 3. So therefore this is a 1, 1 function. Is this onto function? Let us see. Are there elements left over in the codomain? No. So therefore this is an onto function. Let us take the next one. So under the f, the mapping is like this. Let us see if this is 1, 1 or many one, onto or into. Before that, is this a function? This is not a function because there are some elements in the domain for which there is no arrow coming out. So that is not a function. What is the definition of the function? Every element of the domain should have exactly one image. And here this has 0 images. So therefore this is not a function. If it is not a function, then there is no point in discussing if it is one or many one function and is it onto or into function, right? So therefore this is not a function. Of course this is a relation, but this is not a function. Okay, so let us take the next part. Now let us see how do we decide based on the graph of a function if it is a many one function or a one function. Okay, so for that let us take some graphs. Okay, so before we have seen the mathematical way of proving if it is one or many one. What was the mathematical way or mathematical method? Consider f of x1 is equal to f of x2. If the images are same, then if you prove that the elements are also same, then you have proved that this is a one function. Okay, but if you are getting something else other than x1 is equal to x2, then it will be a many one function. So now let us see the graphical method. Now we have to decide if these functions are one or many one by seeing the graph of these functions. There are some functions. We do not know what is this function exactly, but we know the graph of that function. So how do we know? How did we decide before? If you have set x and set y and the elements are like this, okay, let us say x3, y1 and y2. If the mapping is like this, then we said that this function is a many one function, because corresponding to this y1, for this y1, there are more than one arrow which is landing on it. So if you are seeing from the y1's perspective, there are more than one x coordinate, right? So if there is something like this, if the elements are y1, y2, y3, y4, okay, under the f, x and y. Now, is this a one function? Yes, absolutely, because x1's image is different, x2's image is different, x3's image is different. So there can be some y values which do not have an x value. That is fine. But if there is a y value for which there is an x value, then it should be only one x value. You cannot have more than one x value if your function is one function. That's all. Okay. So let us come. So here for this y coordinate, there is no corresponding x coordinate. That is fine. For this y coordinate, there is no corresponding x coordinate. That is fine. For y is equal to 0 also, there is no corresponding x coordinate. That is also fine. But if you come little bit up, then for this y coordinate, there is one corresponding x coordinate. Very good. No problem. Still it passes. For a y coordinate, if you have an x coordinate, then it should be only one x coordinate. Yeah. So wherever you go, it will cut this line only once above x axis. Right. So therefore, this is a one function. Okay. So what did we understand here? If you take a horizontal line parallel to x axis, it should cut if it cuts the graph, it should cut the graph only once. Again, when you take a line parallel to x axis, if it cuts the graph, it should cut the graph only once. That's all. Okay. Clearly you can see, even if there is at least one line for which there is more than, let us say for this is y1, this y coordinate is y1. Corresponding to y1, there are multiple x coordinates. So that means if you have y1 here, there are multiple x coordinates which have output y1. That means this is a many one function. Many one function. Okay. Here, just by seeing only we can say this is a many one function. Okay. Here, any horizontal line you take, if it is cutting the graph, it is cutting only once. So therefore, this is a one function, which is not right, because this is not even a function. Why is it not a function? Because what is a function? For every x coord, for every element in the domain, there should be exactly one image, right? For every element in the domain, there should be exactly one image. But here we have more than one image, right? More than one output value. So if you have something like this, then this is not a function. So therefore, this is not even a function. So there is no point in discussing if this is 1, 1 or many 1. Okay, I hope it is clear. Let us write the same thing as a point here so that you can remember this. If any horizontal line cuts the graph of a function at more than one point, okay, then it is a many one function. Otherwise, it is a 1, 1 function. Okay, if there is any horizontal line, if it is cutting more than once, here 0 is not more than once, right? 1 is not more than once. So here many one function, like that. Okay, fine. A function f maps from A to B is said to be 1, 1 and onto or bijective. So this whole thing you can replace it with bijective. A function f maps from A to B is said to be bijective if f is both 1, 1 and onto. That's all. So let us see and understand what is a bijective function through this example. As I told you, it should be both 1, 1 and onto. That's all. So whenever you're checking if the function is bijective, then you have to check if it is 1, 1 and if it is onto. So you started first checking for 1, 1 function, let us say, and you got it is not 1, 1 function. So there is no point in checking for onto function because already we know that this is not a bijective function, right? So if you are checking for a bijective function, if you get the first one correct, only then go to the second one and see if it is correct. Okay. So in this case, we have the functions mapping like this, and we have to decide if it is a 1, 1 function. So let us start. A's image is 2 and there is no other element sharing this 2. So therefore, the same way with the other ones. So therefore, this is a 1, 1 function. Is it an onto function? Let us see. All of the codomain should be mapped. So here 2, 3, 5 all are mapped. So therefore, onto. Okay, fine. So what is a bijective function? A function which is both 1, 1 and onto. Now let us do some problems. The first problem is Ncrt Example 7. Let A be the set of all 50 students of class 10 in a school. Okay, so you have a set A which contains the students of the class 10 and there are 50 students. Okay, so let f is a function which is mapped from A to n. So therefore, this is our domain, this is our codomain. So take the natural number set here. Be the function defined by f of x is equal to roll number of the student x. Okay, so let us say the students are x1, x2, so on up till x50 because there are 50 students, and f of x means this function will map the student to their roll number. Okay, and what is there in the second set? Natural numbers, and so on like this. Natural numbers 1 to infinity. Okay, so show that f is 1, 1 but not onto. Okay, so to prove that it is 1, 1 function, let us first understand how the mapping is happening. This diagram, this is not needed to be shown in board exams. Okay, this is just for our understanding. Okay, so and for competitive exams, it doesn't matter. However you do, you should give the correct option. Okay, so here, so we have to prove that it is a 1, 1 function but not onto function. So let us say, for example, x1 has a roll number 1. Roll number means one roll number is given to one person, isn't it? That is what is a roll number. So if x1 has a roll number 1, x2 cannot have, or any other element here or any other student here cannot have roll number 1, right? So therefore, x2 will have something else. Let us say x2 has 3, x3 has, let us say 2, and so on like that. So, ultimately 1 to 50 roll numbers are given corresponding to 50 students. Okay, so it will be a 1, 1 function. Why will it be a 1, 1 function? Okay, let us write reason. Reason is every student has a unique roll number. Has a unique roll number. Therefore, if the input values are different, then output values are different. This is the meaning of, means this is what is saying that f is 1-1 function. F is 1-1 function. 1-1 function. Okay. So if you are giving different students to this function, it will give you different roll numbers. So there is no sharing of the images. So therefore this is a 1-1 function. Okay. Now will it be an onto function? Okay. Let me ask you. Now for 50 students we need 50 roll numbers. And in natural number set we have infinitely many positive integers, isn't it? Natural numbers means positive integers. So you are taking only 50 integers out of this. And all of the rest are left over. So that means there are elements in the codomain which are left over. So therefore this will not be an onto function, it will be a into function. So let us write the same thing. F is into function. Reason, in the natural number set, which is our codomain, only 50 elements have mapping, as other natural numbers do not have any mapping, implies range is not equal to codomain, implies into function. Okay, so you can write it in your own words. There is nothing very specific you have to write. Just the reason why this function is not a onto function, right? So let us take the next question. Okay, so let us take the question. Show that f maps from n to n. So this is our domain and this is our codomain. Given by f of x is equal to 2x is 1-1 but not onto. So always it is good to have a set diagram in the rough as far as boards is concerned. As far as competitive exam is concerned, you don't need to do anything. You can do whatever you want. You have to get the answer. That's all. Okay. So let me tell you the way you can approach in boards format. This you need not write. You can have it in your rough. So we have n to n and the function is f of x is equal to 2x. So if you are taking 1 as your input, it will be mapped to 2. If you are taking 2 as the input, it will be mapped to 4. 3 will be mapped to 6 and so on like that. 4 will be mapped to 8, 5 will be mapped to 10 and so on. So is this a 1-1 function? Just by seeing this, is this a 1-1 function? Yes. Why? Because this 2 is not shared by anything else, right? 2 has its image 4, 3 has its image 6, 4 will have its image 8 and so on like that. So nowhere there is any sharing here, right? So therefore, this will be a 1-1 function. Now some of you might be like, how can you say there are infinitely many elements here? How can you exactly say it? It is very simple like this. See, let us say for example, this is y. So 2x. So x is equal to like this. So y by 2 is equal to x. So for 1, if there is any mapping, it should be mapped to 0.5. But there is no 0.5 here. That is why it is left over. For 2, if any mapping is there, it should be half of that. So that will be 1. Okay. So 2 divided by 2 will be only one quantity. It will not be more than one quantity. Okay. So that is one of the explanations you can say that you need not check for all of them. There are infinitely many. What is the reason? If you are taking half of any y value, it will be only one value. And if it is there, then you'll do the mapping. Okay, fine. So therefore, this is a 1-1 function. Therefore, this is a 1-1 function. We came to know through this set diagram. Is it an onto function? Just by seeing, we can say this is not an onto function because some elements are left over in the codomain. Okay. So as I told you, this whole thing is for understanding purpose. Okay. To understand what is this function doing. But the way you need to write in boards is not like this. Let me show you how do we need to write. So we have discussed multiple times how do you prove a function to be 1-1 function. One of the methods is graphical method. The other method is mathematical method. As far as boards is concerned, you have to show the mathematical method. Okay, mathematical method. So how do we do it? Start with f of x1 is equal to f of x2. Ultimately, if you get x1 is equal to x2, only this, then it is 1-1 function. If you get something else other than this, then it will be many-one function. Simple. Okay, so let us start. So consider, this is the way you need to write in boards. Consider x1 comma x2 belonging to our domain, which is natural numbers. Say they have same images. F of x1 is equal to f of x2. Okay, so this part will be same in any question where you are proving it is 1-1 function. Consider two elements belonging to the domain and say they have the same images, then start. What is the function definition? 2x, so input is x1, so therefore 2x1. So here we got x1 is equal to x2. Did we get anything else other than x1 is equal to x2? No, only x1 is equal to x2. So therefore f is 1-1 function. That's it. Okay, fine. So how do you disprove that it is an onto function? Because we understood clearly that this is not a onto function. So how do we prove that? It's very simple. When you're disproving, means again I'm telling you in terms of boards, the way you need to write. Whenever you need to disprove that it is an onto function, then you can show one example. That is sufficient. Okay. How do you show it? Something like this. 1 belongs to natural numbers, which is our codomain. Which is our codomain. Okay. So 1 is an element which belongs to our codomain. So 1 is equal to 2x. So x is equal to half. But half does not belong to our domain. Half does not belong to our domain. So therefore 1 is left over. That is what we have shown here. 1 is an element which belongs to the codomain, but corresponding to that it should be half, which is not there in the domain. So therefore this will not be therefore 1 will not have any mapping in codomain. 1 will not have any mapping in codomain. You can write it in your own words. Okay. So therefore f is onto function. F is onto function. Just you have to show that there is at least one element for which there is no pre-image. Right? This is called pre-image. So for 2, 1 is pre-image. For 1, 2 is image. Okay. For 1, 2 is image. For 2, 1 is pre-image. So for 1, there is no pre-image in the domain. So therefore, it is not a onto function. It is not onto function. Okay, fine. Good. So, you need not write it like this, but just understand the way, we are writing. For all y belonging to the codomain, there does not exist y by 2 belonging to the domain. Right? For all y belonging to the domain, the corresponding value should be y by 2, right? Isn't it? So for y is equal to 2x, x is equal to y by 2. So for y, the corresponding element in the domain should be y by 2. There does not exist y by 2 belonging to domain such that f of what is x? Y by 2 is equal to What is the rule? 2x. So here y by 2 is there. So therefore, write y by 2 on the right hand side. So this is equal to y. So what are we saying here? We are saying that for an element y belonging to the codomain, there is no y by 2 in the domain such that f of y by 2 is y. Right? Simple. This method is used not for disproving. This is used for proving. Okay, that you will see in the next question. So I'm just introducing it here itself so that it will be a extra practice. That's all. But for disproving, you need to show only one example and that is sufficient. Okay, fine. So here we have taken 1. Corresponding to 1, there was no element in the domain. Show that the function f maps from n to n given by f of x is equal to 2x is 1, 1 but not onto. Okay, so let us understand how the mapping is happening using a set diagram, and this will not be needed to be written in the board exam. Okay, so what you need to write, we will be writing, but this is for understanding purpose and this you can have it in your rough. Okay, so here we have a function f which is mapping from n to n and f of x is equal to 2x. So if there is an input x, it will double it and that will be equal to the output value. So if 1 is the input, 2 is the output. If 2 is the input, 4 is the output. If 3 is the input, 6 is the output and so on. 4 is the input, 8 is the output and so on like that. Now, just by seeing this set diagram, is this a 1-1 function? To say if it is a 1-1 function or not, let us see. 1 has its image 2 and I am sure that no other natural number on taking twice of it, you will get 2. Isn't it? Right? So y is equal to 2, this is equal to 2x. Implies x is equal to 1. So there is no other number doubling which you will get 2. There is only x is equal to 1 solution. So therefore, for 1, the image is 2 and there is no other element in natural number set on taking twice of which you will get 2. So therefore, it is the same case with 2 also. 2 is mapped to 4. There will not be any other natural number which will be mapped to 4 and so on like that. So therefore, this will be a 1-1 function. So, okay, very good. And next is how is it a onto function? Okay, so is it an onto function or not? Now, clearly I can see 1 is being left out in the codomain. Now, if you take y is equal to 1, then the corresponding x value will be half. Is x is equal to half there in the domain? No. As domain is our natural number set and half will not be there in natural numbers. So therefore, this one will be left over and we have shown one single example where there is an element left over in the codomain. But there are multiple elements here. There are infinitely elements here which are left over in the codomain which does not have any mapping. 1, 3, 5, 7, so on like that. All the odd numbers are left over. So whenever you are showing that this is not an onto function, if you are giving one single place where the rule of onto function is being denied, that is sufficient. Okay, so let us write it in the board's form. So how do you prove a function to be 1-1 function? You consider something like this. F of x1 is equal to f of x2. And ultimately, if you get x1 is equal to x2, and this is the only solution, then this function will be 1-1 function. And if you get something else, then that will not be a 1-1 function. Okay, so let us write it. Consider x1, x2 belonging to domain. Say f of x1 is equal to f of x2. Okay. Now what is our function? 2x. So therefore, f of x1 will be 2x1 and f of x2 will be 2x2. So 2 is getting cancelled and we got x1 is equal to x2. This is the only solution that we got, and that is x1 is equal to x2. So implies f is 1-1 function. 1-1 function. Okay, fine. So we have proved that f is a 1-1 function. Now we have to show that f is not an onto function. whenever you are showing that it is not onto or not 1, 1, if you give one single example, that is sufficient. So here, let me write it like this. 1 belongs to natural numbers, which is our codomain. 1 is equal to 2x, implies x is equal to half. Half, x is equal to half, does not belong to our domain, right? So what did we show here? 1 belongs to codomain, and corresponding to 1, the mapping would have been happen if half was there in the domain, but half is not there in the domain. So therefore, as 1 an element in codomain has no mapping, implies f is not onto function. F is not onto function. Okay, so we have shown a specific case where an element where it is a part of codomain and there is no element in the domain corresponding to this element 1. You could have taken 3, 5, 7, anything. Okay, fine. So this is how we have proved that this is 1, 1 function, but this is not an onto function. If you are doing the same question in competitive exams, either you can see it here and right away have the answer, right? F of x is equal to 2x, f maps from n to n. F maps from n to n, f of x is equal to 2x. Is it 1, 1 function? Is it onto function? If those are the options, 1, 1, onto, 1, 1, but not onto, all of that. So in that case, you already have the answer. There is nothing to write as if you're writing in boards, right? There is another way of seeing it also, something like this. The graphical method. Here you have y is equal to 2x. Your domain is all natural numbers. So therefore, take 1 here, 2 here, 3 here, 4 here, and so on. Corresponding to 1, the output is 2. Corresponding to 2, the output is 4. Corresponding to 3, the output is 6. So on y-axis, there is 1 also, there is 3 also, there is 4 also. Sorry, this should be 5. So now, what is our codomain? Natural number set. So if you take the range for 1, it is 2, for 2, it is 4, for 3, it is 6, for 4, it will be 8. So all the even natural numbers are being covered in your range, isn't it? What is our range? Range is nothing but set of all output values. So therefore, range of the function will be 2, 4, 6, 8, and so on like this. But what is our codomain? All natural numbers. So that will have 1, 2, 3, 4, 5, and so on like this. Right? So clearly we can see range is not equal to codomain. So therefore this is not a onto function. Okay. So now let us take the next question. Prove that the function f maps from R to R. F of x is equal to 2x. Very simple function. Is 1, 1 and onto. So here we have to prove that it is 1, 1 and onto. And we have to write it in boards format. So let us write in the boards format and understand how to write it. Okay. So now always I told you it is better to have this mapping diagram in your rough. This is not needed to be drawn in boards. Okay. But for competitive exam purpose, from here only you will get the answer. And for board exam purpose, you will get a very good idea how to write your answer from this mapping diagram. So let us take, this is all real numbers. So therefore you'll have all real numbers. I have given only some real numbers. Of course, there are infinitely many real numbers between -2 and -1 also, but we cannot write all of them. So we have taken some. Okay. Next, there is some real numbers here also. This is not relation R. This is real number set. Okay. So we have a relation R, or we have a function f, which is mapping from R to R. And what is it doing? If you are giving an input, it is taking twice and mapping. So therefore, -1 is mapped to -2. Like that, every real number is mapped to someone, right? Now, clearly you can see -1 is mapped to -2. Is there double of any real number also -2? No, right? If you are taking -2, then only minus 1 into 2 is minus 2. There is no other real number for which if you double that you will get minus 2, right? So therefore only one arrow will come on minus 2. So therefore on every, means if you are taking 0 also, twice of 0 is only 0. You cannot have any other real number twice of which is 0. So therefore here it is a 1-1 function. So right away you know it is a 1-1 function. And is it an onto function? Yes, that also, because whatever real number you take, if you take, now what should be the other real number here? If minus 1 is there, means minus 1 is our y, then corresponding x value is equal to minus half, which is minus 0.5. Whatever it is, real number by 2 will be real number only, and that you can see it here. So therefore, for every number here, you will have a number here, right? For every number here, half of this number only I want here. So for every real number, I will have half of this, and therefore this will be an onto function also. So you understood why it is onto, why it is 1-1. Just you have to write it in boards form. Before it was natural number set to natural number set. If you remember in this question, it is from natural numbers to natural numbers. Here it will not be an onto function because 3/2 will not be there in natural numbers, right? So that is the only difference here. So let us complete the problem. Let us write what we have understood. And so how do you prove that it is a 1-1 function? Let x1 comma x2 belong to our domain, and our domain is all real numbers. Say f of x1 is equal to f of x2. This is where we have to start. And finally, if you get x1 is equal to x2, then it is 1-1 function. Here we have to prove that it is 1-1 function. So when you're proving, you have to prove by this method. If you're disproving, if you show one example, that is sufficient. So here f of x1 is equal to f of x2. 2x1 is equal to 2x2. Implies x1 is equal to x2. So as if f of x1 is equal to f of x2 implies x1 is equal to x1 is equal to x2. Therefore, f is 1-1 function. This is the way you have to write in boards. Okay. So we have proved that this is a 1-1 function. Now let us prove that this is an onto function. The way we have to write is something like this. For all y belonging to R, which is our codomain. Okay. So for all y belonging to R, there exists an element. Okay. So when you are proving that this is an onto function, all that you want to prove is only one thing. That is, every element here has a mapping, right? So if you choose any element here, if you choose any element in our domain, then corresponding element here will be what? Very simple. Y is equal to 2x implies x is equal to y by 2. So therefore, if you have y here, there is an element y by 2 in our domain. There exists an element y by 2 belonging to R, which is our domain. Such that, okay. Now, this is the final line. So, y is there, y by 2 is there. What is the importance of this y by 2? The importance of this y by 2 is f of y by 2 is equal to 2 into y by 2 is equal to y. That is what is the importance. Y is there here, y by 2 is there here, and y by 2 is mapping to y. So therefore, every y has a mapping. That is what we have proved here. Okay. So f of y by 2, f of x is 2x, f of p will be 2p, f of laddu will be 2 into laddu, right? So therefore, f of y by 2 will be 2 into y by 2. So therefore, you got y. That's all. So therefore, f is onto function. Got it? So what did we prove? F is 1-1 function and f is onto function also. How did we prove? How did we write? Very simple. You consider any element y in our codomain. There exists an element y by 2 in our domain such that f of y by 2 is equal to y. That's all. So f of some element, some real number is there which is mapping to this y. So what is that y? What is that some element? Y by 2. That is what we have shown here. Okay. So writing is also very simple. So we have proved that this function is both 1-1 and onto. So otherwise you can do it like this also. Instead of doing all of this, do we know the graph of this function? Yes. So how is the graph of y is equal to 2x? Like this. Correct? This is origin. This is y is equal to 2x. A straight line passing through origin, right? Okay, so now all real numbers is our domain. So all real numbers. Okay, so we have to take the whole graph. Our consideration is whole graph. Now for this whole graph, if you take a horizontal line, it will cut the graph only once, right? Never it is cutting more than once. So therefore this is a 1-1 function. 1-1 function. Because corresponding to every value of y, there is only one value of x. So there is no two values of x going to one value of y. So therefore this is 1-1 function. Is it an onto function? Very simple. For all real numbers as input, what are the outputs? Okay, let us first shade the graph. This is the part of the graph we are interested in, isn't it? All real numbers are input, whole graph will be in our consideration. For all of this, what are the y values? Least y value is minus infinity. And all the y values are being taken, right? All the y values are being taken. And therefore, till infinity. So therefore, range of the function is all real numbers, which is same as codomain. If codomain and range both are same, that means this is onto function. So therefore, implies f is onto. That's it. Done. Okay. So we have proved that f is 1-1. We have proved that f is onto. This is the way you have to do in like competitive exams. And if you want to do like this also, it's fine. But you know, this is not the right way for competitive exams. First way is this one. Okay. And if you happen to see it like this also, it is fine. Because even before you draw, you will have it in your mind. Okay, this is what is happening because of this function. So therefore, already you will have the answer. But if you know the graph, then do it graphically. Okay, fine. So first method, second method for competitive exams. For boards, anyway, you know how to write. Okay, so let us take the next question. Show that the function f maps from R to R, f of x is equal to x square is neither 1-1 nor onto. So here we have to disprove that it is not 1-1 and it is not onto. So that is very easy. If you give one example, that is sufficient, right? So in competitive exams, how do you do? You don't know this, okay? We have to see if f of x is equal to x square is 1-1 or not, onto or not. So for that, because the graph is known, just take the graph. Okay, you have the graph parabola, right? So once you have the graph parabola, just see, is there any horizontal line which cuts the graph more than once? Yes, lot of horizontal lines are there which are cutting the graph more than once. So therefore, this is not 1-1. So this is not 1-1. Fine. So half of the problem is over. So you have decided it is 1-1 or not. It is not 1-1. Is it onto? Find the range of the function. So here, what is our domain? All real numbers. If domain is all real numbers, then the graph which is under consideration is the whole graph. Okay. So for all real numbers as input, these are the y values. What are the y values? That is range of the function. So range of the function is starting value of y is 0 till infinity, which is not equal to codomain, right? So therefore, codomain and range are different, means this is not onto. So answer is there. So now let us write the same thing in boards format. In boards format, to disprove that it is not 1-1, just give an example. So x square only. So if you take this mapping diagram, clearly you can see that -1 square is also 1, 1 square is also 1. So therefore, -1 and 1 have the same image. So therefore, this is not -1 square is 1 and 1 square is equal to 1, but -1 is not equal to 1. Implies f is not 1-1. F is not 1-1 function. We have proved that there are two elements which are not same, but their images are same. So therefore, this is not 1-1 function. And is it an onto function? No. You just have to write the same thing. So -2 belongs to R, which is our codomain. And we know square of any real number cannot be -2. So therefore, f is not onto. So this is the way you are writing. But ultimately, what you know, that square of any real number will not be a negative number. So that's what we have shown with small one example. But all the negative numbers do not have any mapping. So therefore, codomain is not equal to range. So therefore, this is not an onto function, right? So simple. Let us take the next question. F maps from n to n be defined as f of n is equal to n plus 1 by 2 if n is odd and n by 2 if n is even for all n belonging to n. State whether f is bijective. Justify your answer. So here there is a small change. Before we had f of x is equal to 2x, f of x is equal to x square, one definition, right? Here we have two definitions based on the input. If n is odd, then you have to use this definition. If n is even, you have to use this definition, right? That is the only difference here. Now, if it is competitive exams or board exams, I told you, just have this mapping diagram and right away you will understand the answer. If you know the graph, go to the graph, right? But here, this is like a piecewise function. So let us take the mapping diagram. Okay. So if you're taking the mapping diagram, what will happen? Here we have natural numbers. Here also we have natural numbers. And here in natural numbers, we will have 5 and so on like this. 1, 2, 3, 4, 5 and so on like this. 1 is an odd number. So you have to use this definition. So 1 plus 1 by 2, that is 1. So therefore, the mapping is like this. So 1 will be mapped to 1. Now, if the input is 2, then you have to use this definition. 2 by 2 is 1. So therefore, 2 is also going to 1. So already you know this is not a 1, 1 function. Next, let us see if it is onto or not. 3. What is the output for 3? You have to use this definition. 3 plus 1 by 2. 4 by 2, which is equal to 2. So therefore, 3 will go to 2. 4 also will go to 2, right? 5 will go to 3. 6 also will go to 3. 6 also will go to 3, right? So clearly you can see all of them are getting filled, right? 4 will be mapped from 7 to 8, 7 and 8. 5 will be mapped from 9 and 10 and so on like this. So all of them are getting filled. So therefore, this is a onto function, isn't it, right? Everything is getting filled in our codomain. So therefore, range is same as codomain. So the same thing we have to write in boards format. So first thing is you have to disprove that it is 1, 1 function, right? Okay. So if you have to disprove that it is 1, 1 function, let us just understand one thing. See here, state whether f is bijective. Okay. So when do you call a function bijective? If it is 1, 1 and also onto. Okay. So 1, 1 should happen and onto should also happen. Let us say, for example, you first checked for 1, 1. In this case, we checked, right? So this did not happen. So is there a necessity to check for onto? Even if it is onto or even if it is not onto also, this is not a bijective function. So that's all. So once you write it is not 1, 1, actually the solution is completed. Okay. So therefore, when you have this question in competitive exams, directly you have the answer. It is not 1, 1. Let us say you checked for onto. It is not onto. Then it is not bijective. Why do you want to check for 1, 1 also, right? So here we will write both of them. So f of n is equal to n plus 1 by 2 if n is odd and n by 2 if n is even. Okay. So here f of 1 is equal to 1 plus 1 by 2, which is equal to 1. F of 2 is equal to 2 by 2, which is equal to 1. I hope you are understanding. This is odd, this is even. So therefore, we are using the definitions. So now as f of 1 is equal to f of 2, but 1 is not equal to 2, implies f is not 1, 1. F is not 1, 1 function. So we have given an example. We have contradicted that it is not 1, 1 function. Sufficient. Okay. Let us take, we have to show that this is onto function. If you remember, how did we show before that it is onto function? For every value of y, there is a corresponding value. Before it was y by 2. In f of x is equal to 2x, we got y by 2. Here also the same thing. We have to write that. So let us see, let me show you here. Once again, it will be easy to write once you have this understanding. 5. So 1, 2, 3, 4, 5, 6 and so on, right? So 1 is going to 1, 2 is also going to 1, 3 is going to 2, 4 is also going to 2. Like that, 5 is going to 3, 6 is also going to 3. So therefore, if you have a value of y, you are having two things which are mapping to it. So that is all we have to prove. You take any value of y here. You have two things mapping to it. One is 1, one is 2. So this is coming because of odd definition, right? This definition, odd definition. And this is coming because of even definition. So that is what we are going to show now. So you consider any value of y belonging to, okay, consider any value, any y belonging to n, which is our codomain. We have considered any y which is belonging to our codomain, then there exists. Okay. So now what is happening here? For y, if it is an odd number, then what is the corresponding value of x here? 2y, because y is equal to n plus 1 by 2. Implies n is how much? 2y minus 1 is equal to n. So corresponding to y, there is 2y minus 1 in our domain, right? Not only 2y minus 1, there is other one also. Okay. So for y, we have n by 2 also. Means n is equal to 2y. So we have 2y minus 1 and 2y. Both are there for y. That is what we have to show. Okay. So there exists 2y minus 1 belonging to n, okay, which is our domain, and 2y belonging to n, which is our domain, such that before, if you remember, what did we show? F of y by 2 is equal to y. Here also we have to show the same thing. Okay, f of 2y minus 1. What is f of 2y minus 1? Is 2y minus 1 odd or even? 2y is even. From even number you go one less. 1, 2, 3, 4, 5. Okay, this is our even number, right? From here you go one less. That will be odd only. So therefore 2y minus 1 is odd. So therefore I have to use this definition. So therefore 2y minus 1 plus 1 divided by 2, which is equal to, 1 is getting cancelled, 2y by 2, which is equal to y. So we got, there also we proved f of y by 2 is equal to y. Here also we got the same thing. But there are two things here. F of 2y minus 1 is also y. F of 2y is also y. Okay. So below this, we will write that. And that is f of 2y. What is the input? Even number. So if it is an even number, you have to use this definition. So therefore, this is equal to 2y divided by 2, which is equal to y. That's all. So we have, for any y belonging to our codomain, we have 2y minus 1 and 2y, such that f of 2y minus 1 is y, f of 2y is also y. So therefore, finally you will write, therefore f is onto function. Therefore f is onto function. That's all. So in this way we have proved that this is not 1, 1 but onto. So on the whole, therefore as f is not 1, 1 and onto implies f is not bijective. F is not bijective. Okay, clear? Let us take the next question. So here in this question we have f is mapping from R to R. F of x is equal to x power 4. Okay, so note even power like x square, okay, x power 4. Choose the correct answer. F is 1, 1 onto not 1, 1 onto 1, 1 not onto, all of these things, right? So now just by seeing also we can say it is like x square only, even power is there. So minus 2 power 4, let us say. Minus 2 power 4 is 16. 2 power 4 is also 16. So therefore, this will not be 1, 1 function. And next is, will it be onto function? Here we have all real numbers. So let us see if we have, okay. So here we have all real numbers, correct? So in real numbers, we have negative real numbers also. If you are taking power 4 of any real number, how will it be negative? It will not be negative. So therefore, whatever real numbers are there, which are negative, they don't have any mapping, because power 4 of any real number will not be negative number. So that's all. So here we have to write the same thing. So minus 2 power 4 is 16 and 2 power 4 is 16 implies minus 2 power 4 is equal to 2 power 4, but minus 2 is not equal to 2 implies f is not 1, 1. F is not 1, 1. And to disprove that it is not onto, again give an example, that's all. So minus 2 belongs to R, which is our codomain. But there does not exist any element in our domain in our domain such that taking power 4 we get minus 2, as we know that taking power 4 on any real number will never be a negative number. Okay, so that's all. So here we have shown that minus 2 is an element which is there in our codomain, but there is no element in the domain, power 4 of which will be minus 2. So, and we have given a reason also. So that's all. So in this way, we have done the problems. Now, if it is the same problem in competitive exams, then how will you do? Very simple. See, just by seeing, I can say minus 2 power 4, 2 power 4, it is the same y value. So therefore, this is not 1, 1. Is it onto? It is not onto, because x power 4 will not give negative numbers. But if you want to draw the graph is also very simple. X square graph, x power 4 graph, x power 6 graph, x power 8 graph, x power 2n, okay, where n belongs to positive integers. Means, I hope you understood, that is x square positive integers. So therefore 1, okay, 2, or you can write natural numbers, that will be, or natural numbers. So x power 4, x power 6, x power 8, all have same type of graph, that is not parabola, but it is like this only. All have same type of graph, okay. Even if you take x square, it will be little different. Let me show you for y is equal to x power 4 and x square. If you are taking x square graph, okay, it will be like this, okay. It will be like this, okay. So here we have to draw little differently, because, okay, let me first draw it. So first here we have minus 1 and here we have 1, and between minus 1 and 1 x power 4 will give, okay, so like this. Like this, okay, same shape, just, so here means less than minus 1, x square will give lesser y value, x power 4 will give more y value. If you take it minus 2, then minus 2 power 4 is 16. Minus 2 square will be 4. So therefore, here y value should be lesser one, here y value should be bigger one. So therefore, this graph will be more. Between minus 1 and 0, let us say minus half. So minus half square is equal to 1 by 4, and minus half power 4 is 1 by 16. If denominator is bigger, then this will be smaller. So therefore, x power 4 graph will be down and x square graph will be up. So here also the same thing. Okay. So in between 0 and 1 also same thing. And after that, this will come down and this will go up. Okay. So the same thing with x power 4, x power 6, x power 8, all of them, it is the same thing. So let me show that also for you. If you are taking x power 6 graph, then x power 6 graph should be even more y value. And after this, it has to give lesser y value, and like this and like this. Okay. Got it, right? This is y is equal to x power 6. So at minus 2, if you are taking minus 2 power 6, that will be bigger y value. So therefore, this y value should be bigger and this y value should be smaller. So here this graph will be like this. Here it will go down. Here it will go down and here it will come up. So on the whole, the graph is same like y is equal to x square. So what are we interested in? This will never give negative y values. So therefore this is not onto. That's all. And if you can clearly see there are horizontal lines which cut the graph more than once. So therefore this is not 1, 1. So graphically also you can do it. Now let us take some CET questions. So I have already told you, and I am going to remind you once again, that if you know the graph of the function, always do the solution using graph. You will come out with no mistake because you cannot make any calculation mistake in the graph. And the answer also comes very quickly. So let us take the questions and let us do one by one. On the set of integers, f is mapping from set of integers to set of integers. F of n is equal to n by 2 if n is even, and 0 if n is odd. So if input is even, you should do half of the input, and if input is odd, then the output is 0. So is this function 1, 1 function, or is this function onto function or not? This is what we have to see. Now while reading the question itself, I can make out, see, for any odd integer, the output is 0. So all odd integers are going to 0, means this is a many one function. So once you know that this is many one function, means it is not injective. So because this is not injective, option A is not correct, option D is also not correct. So we have not injective in both places. So we will check for onto function. Now here n by 2 if n is even. So let us make one mapping diagram, set of integers and set of integers. And let us take some -3, -2, -1, 0, 1, 2, 3, -3, -2, -1, 0, 1, 2, 3, and so on like this, right? So now under this function f, all odd integers are going to 0. So -3 is going to 0, -1 is going to 0, 1 is going to 0, 3 is going to 0. So anyway, 0 is, mapped. Now -2 will go to -1, and 2 will go to 1, and 4 will go to 2, right? And -4 will go to -2. So now in the small thing that we have done now, -2, -1, 0, 1, 2, they are filled, right? Okay. So what is happening? So -4 divided by 2, that will go to -2. So if you are considering -2, then -2 into 2, that will be -4. -3 into 2, that will be -6. So -6 will be mapped to -3. So 6 will be mapped to 3. 4 will be mapped with 8. And if you're taking 5, 10 will be mapping to 5. So basically 8 will be mapped to 4. Now what about 9? 9 is odd. So therefore it will go to 0. So finally what we want, all of the codomain should be mapped. Is it mapping? Yes. -3 into 2. That will also be integer, and that will be mapping to -3. -4, it will be mapping -8. So -5, -10, so on like this. So basically we have codomain is equal to range. So therefore this is onto function. Onto function means surjective function. So surjective function, but not injective function. Okay, so let us take the next question. F maps from R to R be defined by f of x is equal to 1 by x. We know the graph, we will do it by graph. For all x belonging to R, then f is. Okay, so now this is 1 by x graph. Okay, what is our domain? All real numbers. So for all real numbers, there is 0 in our domain, right? So for 0, there is no corresponding y value. So if you are taking our domain and codomain, so here we have 0, and 0 does not have any y value. So if there is, what is the definition of function? Definition of function is every element of domain should have exactly one image. So every element of domain, whatever are there, one arrow should compulsorily come out. So here 0 does not have any arrow coming out. If you are seeing from here, 0 does not have a corresponding y value. So some elements in our domain are left over. Means this is not a function. So therefore this is not defined. That is the correct answer. Got it, right? Okay, so let us go to the next question. F maps from n to n defined by f of n is equal to n plus 1 by 2 if n is odd, n by 2 if n is even, then f is. The same question we have done just before in the same video. That is NCRT question itself. What did we get? We got this is our codomain. So we are having 2 arrows coming on 1, 2 arrows coming on 2, just before we have done, right? 2 arrows coming on 3. So therefore, this is onto function, but this is not 1, 1 function. This is not 1, 1 function. So not 1, 1, not 1, 1 and onto. So therefore, option A is our correct answer. Just before we have done this problem. Let us take this question. F maps from R to R defined by f of x is equal to x power 4. I told you the graph also. The same question has come in CT. So x power 4 graph we have discussed. It is not parabola, but it is like parabola only, like this. Same type as x square. So this should not come down. It is like this. Okay. So now we have the graph of y is equal to x power 4. Even before we have discussed, this is not 1, 1 and this is not onto. F maps from R to R. So all real numbers are there. Okay. So whole graph has to be considered. There are a lot of lines which are cutting the graph more than once. So therefore, this is not 1, 1 function. And is this onto function? What is the range? 0 to infinity. This is the range of this function, set of all y values. And that is not equal to codomain. So f is neither 1, 1 nor onto. Based on what we have studied, okay, you will be able to do all the problems. You can take any book, keep solving, practice, and I hope that you will, cover all the problems without any doubts. Okay.